today we're going to learn about circuits with Circuit Scribe. Circuit Scribe is a cool ecosystem of components that allows us to play and learn at the same time. For this first project, you're going to need your power module with a battery. You're going to need your LED module and your conductive ink pen, as well as a steel sheet. So we're going to turn to page 5 and talk about how circuits work. Current is going to flow from the positive side of your battery through the line, through the wire most times, but in this case, we're going to use our conductive pens to draw traces, and it's going to go through the positive side of our LED and then to the negative side of our LED and back to the negative side of our battery. Here in our inventor's notebook, we can follow the diagram that they have drawn for us, either one of these, and we can fill in our traces. If you have your piece of paper instead, you can use the stencil that they provide. So from here, we're going to draw our traces. Then we're going to take our battery and line it up the way that the battery lines up here. So negative on the top and positive on the bottom. The reason that this is sticking is because I have my steel sheet underneath. When you put your steel sheet underneath, you've got these magnets on the underside of your components. We're going to stick that down there. We're going to take our LED and put it on the other side. LED stands for light emitting diode, and a diode is an electrical component that only allows current to flow in one direction. So in this circuit, we have current coming from our battery, the positive side, going through our LED and going to the negative side. So when we turn it on, we can see that our LED turns blue because there is a blue LED wired in this component with its positive side on this end and its negative side on that end. This is in fact a bidirectional component, so if I flip it around, there's a red LED wired in the other direction with the positive on this side and the negative on that side. In fact, when we take a closer look at the LED itself, at this little LED component, we can see that the circuit diagram is actually drawn on there. So it says red, blue LED at the top. This little squiggly is a resistor symbol. And this triangle with that line at the end and this arrow coming off of it is the symbol for an LED. So we can see that on one side we have an LED that's wired one way with the arrow pointing here to the right. And on the other side we have an LED wired the other way with the arrow pointing to the left. Circuits have to be complete in order to work. If a circuit is not complete, the current cannot flow properly. So we're going to play a game with some things in our house and see if they are conductive or not. We're going to fill in these traces, but we're going to leave a gap right here and test different materials from around our house to see if they actually make the circuit complete or not. While drawing your traces, make sure that they are shiny and fully connected, or you could get a false negative while testing your materials. Now that I've drawn my circuit, I've gathered some items from around my house that I'm going to test the conductivity of. I have an eraser, a key, a silver paperclip, and a white paperclip. Now that we've finished drawing our circuit, we're going to add our components. So we're going to put the battery on here. We'll put it positive side up because that's what's in the drawing. We'll put the LED on the other side and turn the battery switch to the on position. Nothing happens. Our LED does not light up because paper is not conductive. First, let's test our key. Stick it down here. It's made of metal. LED comes on. Fantastic. Keys are conductive. Next, let's test our eraser. Eraser, stick it here. Eraser is made of rubber. LED does not come on. Not conductive. Next, let's test our paperclip. Paperclip is made of metal and the LED comes on. If your paperclip is not making your LED come on, try pushing it into your sheet of paper. Last, let's test our white paperclip. Our white paperclip is also made of metal, and so we would think it would make our LED come on, but it does not, because the white is actually plastic, and so that's coated metal, and coated metal is not conductive. The next page in our engineering notebook tells us to write our name in our circuit. I'm going to do mine on this blue cardstock so I can show you how to use the stencil. The stencil has holes in it that line up perfectly with the pads that have the magnets in them in the component. I'm going to draw my 4 contact points. Now I'm going to connect them with some cursive writing. You could technically use print writing if you put a line underneath it, but it does need to be connected in order to be a complete circuit. Next, I'm going to slide my steel sheet under my cardstock so that my components will stick. I'm going to place my battery component, place my LED component, and switch the battery on. Thanks to Circuit Scribe for sponsoring this series of educational videos. All of the components in this video are available for sale on the Circuit Scribe website. Use code BerbawyMakers to get 15% off. Also on the website is troubleshooting if you have trouble with your pen or any of their components, and you can also sign up for their live classes. I'm Miss Berbawy. Tune in next time to learn about switches.